Now, welcome to another class on dimensional analysis. Now, dimensional analysis, we're going to be given some aspects on dimensional analysis. Now, dimensional analysis is just an aspect in which to show if the formula is correct. Now, that's the major function of the dimensional analysis. So it is just in order to test the validity of the physical equations. That is it. Now, the dimension of the physical quantities, we have different dimensions of the physical quantities, and this dimension shows the relationship among the physical quantities. Now, if you are talking about the fundamental quantities, don't forget the fundamental quantities, we have it to be LT meter. These are the fundamental quantities, and in which this L stands for length, this T stands for what? Time. This M stands for mass. The E stands for electric current. The T stands for temperature, and in which the A stands for amount of substance, and the L stands for luminous intensity. Now, these are the dimensions. These are the These are the fundamental quantities. Now, let's talk about their units. The unit of all these fundamental quantities. For the length, we have the unit to be meter. For the time, we have the unit to be seconds. For the mass, we have it to be kg. For the electric current, is measured in ampere. Temperature is measured in Kelvin or degrees Celsius. Amount of substance is measured in mole, and luminous intensity is measured in candela. Don't forget. Now, what are the dimensions for all this quantity? The dimension for length is capital L. The dimension for time is capital T. The dimension for mass is capital M. The dimension for the electric current is I. And the dimension for temperature is K, or we use theta. The dimension for the amount of substance, we use N. And dimension for the luminous intensity, we use G. Now, let us see in such a way that we can calculate some dimension of some questions. Now, the first one. If you ask to calculate the dimension of area, don't forget that area is length times length, or we say length times breadth. It is either length times length or length times breadth. And area is, don't forget that the length, one length is measured in meter and another length is measured in meter. So dimension for area will now be L squared, because dimension for a length is L and dimension for another length is L, or we have it to be meter times meter is meter squared. And meter squared, the dimension for a single meter is L, and that will be L squared. Number 2. If you talk about the volume can either be length times length times length, or we use the length times breadth times height. Don't forget that all this, the length here is measured in meter. Length here is also measured in meter, breadth is measured in meter, height is also measured in meter. So all these are what? Are meter cube. So because they are meter cube and a single meter, the dimension of a meter is capital L. Or if you use length, length is L. And that's why we have it to be L cube. Number 3. We need to calculate the dimension for velocity. Don't forget that velocity is measured in meter per seconds. So I can use units to calculate dimension, or I use the formula. Now because velocity is measured in meter per seconds, and what's your meter? Your meter is L, dimension for meter is L, and seconds is T. So that means we have the velocity to be LT raised per minus 1. That's LT raised per minus 1 from meter per seconds. The same thing applicable to speed. Speed is also measured in meter per seconds. And that's also LT raised per minus 1. Or if you use their formula. If you use formula method, don't forget that velocity is displacement over time. And displacement is measured in meter. Time is measured in seconds. So this will also be, since displacement is meter and dimension is L, over time, which is seconds, and that's T. And this is also LT raised per minus 1. So you can either use the formula or you use their units. Number 5. If you are asked to find the dimension for acceleration, don't forget that acceleration is meter per second square. So because the unit for acceleration is meter per second square, dimension for meter is L, dimension for seconds is T, then raised to power what? Minus 2. So the best method you can use very fast is the unit, for those that know the unit very well. But for the aspect of the one that's maybe they are, the quantities are very complex, then you should use what? You should use the formula. Now, number 6 now. Number 6, if you're asked to find the dimension for density, density will be mass over volume. Now, we all know that mass is measured in kg and volume is meter cube. So dimension for kg, the dimension for kg, because kg is for what? Is for mass, and dimension for mass is capital M. So we have this to be M over, we have meter to be L, and this one is meters cube. So in which we have this to be M L raised per minus 3, because if you take this up, it becomes minus. So if it is negative before, it becomes plus. But if it is plus before, it becomes minus. Now, number 7. Number 7, if you ask to find the dimension for the force, don't forget that force is mass times acceleration. Mass is measured in kg. Acceleration is meter per second square. Mass is measured in kg. Acceleration is meter per second square. So if you check this, the dimension for mass for kg is capital M. Dimension for meter is L. Dimension for seconds is T. So raised per minus 2. If you combine these two together, this will give us MLT raised per minus 2. So to give us MLT raised per minus 2. Now, number 8. If you ask to find the dimension for work done, the work done is force times distance. Now, if work done is force times distance, we've calculated the dimension for the force here, and that's MLT raised per minus 2. Multiplied by the distance is L, because it is measured in meter. Don't forget, distance is measured in meter, so that's L. If you now multiply this together, this L will come and multiply this L here. So this one will come. So we have L squared, because L times L will be L squared. Then we have T raised per minus 2. We have M here. L comes to multiply the L here, which becomes L squared. Then we have T raised per what? Minus 2. Number 9. Number 9, we have the dimension for the power. Now, power is work done over time. And what's your work done? We've calculated work done here. And the work done we have here is ml t raised power minus 2 all over what? All over t. Now, if you have this, then let us balance this equation. We have it to be mlt, ml raised power 2. Then you know that we have t raised power minus 2 here. Then if this t at the denominator has the power of 1, if it goes up, it becomes what? Minus 1. So finally we have ml raised power 2, then t raised power minus 3. So that is the dimension for the power. Number 10. Before I go into the word aspect of the words of dimensional analysis, we have stress. Stress is force over area. And what's our force here? Force dimension is ml t raised power minus 2. You have to know the formula, the dimension for force offhand without calculating after you've gone through the method of calculation. And area is L squared. Don't forget you've calculated that. Then this becomes L raised power. The L at the numerator here is 1. So if the L here at the denominator goes up, you know it is 2. If it goes up, it becomes what? Minus 2. So we have t raised power minus 2 at the numerator. Then finally this becomes ml raised power minus 1, then t raised power minus 2. Because 1 minus 2 will be what? Minus 1. Then let's calculate the 11th one. The 11th one is coefficients of viscosity. Now what's coefficient of viscosity? Coefficient of viscosity is force times distance all over area multiplied by velocity. Or you can just say force over area multiplied by distance over velocity. Or we use force over area divided by velocity gradient. It's still the same thing. So if you say divided by velocity gradient, because velocity gradient is velocity over length. If you've gone through the aspects of the scalar quantity and the vector quantity, you should know what I'm talking about. Now if you are using this, force here has the dimension to be ml t raised power minus 2 all over, or let's say multiply by distance dimension is L, all over area is L squared, then multiply by velocity is lt raised power minus 1. Don't forget, this will finally become, let me use another one. Let me use here. This one will finally become, if you multiply this will become ml squared, then t raised power minus 2. That's for the numerator. L times L here will be L squared. Then we have t raised power minus 2. Let's come to your denominator. L squared times 1L here will be L cube. That's, law of indices. That'll be L raised power 2 plus 1 here. That'll be L cube. Then we have the t raised power minus 1. Then let us collect the like times. We have m at the numerator here. Then we have L raised power 2 here. If this L goes up, it's positive, it becomes what? Minus. So that's why it is minus 3. Then we have t raised power minus 2 here. If this t goes up, because it is negative 1, so it will be plus 1. So finally we have L raised power minus 1, because 2 minus 3 will be minus 1. Then t raised power minus 1. This is the dimension for the coefficient of viscosity that we have here. So that is the final aspect of each quantity. Now let's get into the word aspect of the dimensional analysis. The question says, the equation of motion governing an object, total distance is given. Solution is given by x equals ut plus half at squared, where x is distance, U is initial velocity, V is final velocity, C is time. We are asked to show that the expression is dimensionally correct. Now to show, you just have to note that your left hand side must be equal to right hand side. Now, left hand side must be equal to right hand side. Now the dimension for x, because x is distance, it will be L, equals to, the dimension for velocity is L_t raised power minus 1. So multiply by, dimension for time is t, so plus. You can remove this because dimension of numbers, if you have numbers, not power, dimension of coefficient numbers is 1. Let me say is 1, yes. So it is 1, so you remove it. The dimension of it is 1, or let me say it is dimensionless. So dimension of numbers is dimensionless. So we have it to be dimensionless. So that's why this 1/2 will be removed. Now into the bracket of dimension of acceleration is L_t raised power minus 2. If you go through the method we did the other time, and dimension of time is t. So but the t here is raised power 2. So that's why we have the square here. But it is only the power you can recognize. So now we have L to be equal to, if we multiply this, the t will come and multiply the t here. So we have L. Then if you check this very well, this one will be t raised power minus 1. And the power here on this t is plus 1. So that's why. So plus, let's get through this one. This one will also be L t raised power minus 2 that is here. But if we multiply law of indices, then this will be plus 2. Because you take a base, but the power will multiply each other. Now we have L to be equal to L, because this one is minus 1 plus 1 will be 0. So anything raised by 0 is 1. So plus L as well, because this one will also be 0. And anything raised by 0 is 1. So we have L to be, L plus L will be 2L. So L is equal to L. Because don't forget, I told you that dimension of any number, coefficient numbers, is dimensionless. So left hand side is equal to right hand side. So that shows that the formula is what? Is correct. Number 2. Let us take a look at some cases before I further on the word aspect of the calculation. Some cases of quantities with the same dimension. Quantities with the same dimension. Now we have some quantities that have the same dimension. Now for instance, work, energy, torque, and moments of a force. They have the same dimension. This category of quantities have the same dimension. Don't forget, work is measured in joules. Energy is also measured in joules. So all these have the same dimension. Another one is stress, pressure, and Young modulus. They also have the same dimension. We also have another one. We have length, we have the breadth, we have the width, we have the radius, we have distance, we have displacement, we have amplitude, we have height, we have altitude, we have depth. All these, they also possess the same dimension. They also possess the same dimension. Number 4. We have frequency. We have angular velocity. We have velocity gradient. We have the decay constants, they also have the same dimension as they are. Number 5, we have linear momentum, linear momentum and impulse. Linear momentum and impulse also have the same dimension. Number 6, we also have weight, we have force, upthrust, thrust. They also have the same dimension. Can have the frictional force. So all these, they are forces. So they have the same dimension. Number 7. Number 7, we have the impedance, and we also have electric resistance. They have the same dimension. Number 8, we have speed, we have velocity. So they also have the same dimension. We have potential difference and EMF, that's electromotive force. They also have the same dimension. So I believe this is enough. Let me give another one. That's number 10. We have the surface energy. We have the surface tension. And we have the stiffness. They also have the same dimension. So these are the categories of quantities with the same dimension. The quantities with the same dimension. So now let's proceed to our word aspect of the question. The second question. The question says, the speed c of an ocean wave is proportional to the acceleration due to gravity g. So our g here is acceleration to gravity. Wavelength lambda, so this is lambda, and the density of the wave such that c is kg raised power x, the wavelength raised power y, the density raised power z. Now so where k is dimensionless, so this k is dimensionless, so we can remove it for now. Now so the correct equation for the speed of the ocean, which is this c, is dash. Now the correct equation will now be, now the only thing we just need to do is make the left hand side to be equal to right hand side. Now c is speed, and the dimension for the speed is Lt raised power minus 1. Don't forget, as I started this lecture, I gave it to you. G is acceleration due to gravity. G is acceleration due to gravity. And all acceleration, don't forget, speed is Lt raised power minus 1. Acceleration is Lt raised power minus 2. That's it. We don't need to waste our time. So acceleration is G, and that's Lt raised power minus 2. We have lambda. Lambda is measured in meter. That's the wavelength. The wavelength is measured in meter. They even said it, that wavelength. So it is length, wavelength. So it's measured in meter, so the dimension will be L. And we have density. I gave you the dimension for the density. So density is mass over volume, and it is ml raised power minus 3. So we have the density, so that is density, and that's ml raised power minus 3. So now let's get into the equation back. So this c is Lt raised power minus 1 equals to, we are going to leave the k for now. We are going to include it later, but we just need to pen it when we are dealing with dimension, because it said it is dimensionless. K is dimensionless. So what's dimension for G now? G is Lt raised power minus 2 and all raised power what? X. into the bracket of lambda. Lambda is L. The dimension for lambda is L, and it's raised power what? Y. And what you have here is density, and it is ml raised power minus 3, and it is raised power what? Z. Now let us open this power. We have L2 raised power minus 1 to be. Use the power to open this bracket each. X times L here, we have it to be L raised power X here. Then we have minus 2 times X here. So we have T raised power minus 2X. And at the same time, we have for this one, we open this power, it will be L raised power Y. And let's use this to open the power. We have, the power of M here is 1. So 1 times Z, that's Z. So we have M raised power Z. The minus 3 times Z here will be minus 3Z. Now this becomes L2 raised power minus 1, which is equals to. Now let us collect the like times. If we are to collect the like times, we are to bring all the L together. Don't forget, let me remind us of the law of indices. The law of indices that says that if you have a raised power x multiplied by a raised power y, then if it is multiplication, it will be a raised power x plus y. So you can see that they have the same base. So if they have the same base like this, you are going to pick a base, but it should be raised to the power of the first power, then plus the second power, because it is multiplication. But if you have a raised power x divided by a raised power y, since it is division, then this becomes a raised power x minus y. So this is the law of indices that we are going to be using here. So you have one L here, and another L is here, another L is here. So don't forget that the sign between all of them here is multiplication. So it now becomes L raised power x, then plus the other one, which is y, then plus the other one, which is minus 3z. That's it. Because you have it to be what? Multiplication sign in between, according to this law. Then the next one we deal with is t. And t here we only have 1. And it's only raised to power what? Minus 2x. And we have the next one to be z, to be m. And m here is raised to power what? Z. Now with this, we have it to be LT raised to power minus 1 to be L raised to power x plus y. So don't forget, we have to open this bracket. Plus times minus will be minus. So we have this will be minus 3z, then t raised to power minus 2x, then m raised to power z. Then after getting to this level, we now need to separate this into MLT. We separate this into MLT. Now if you check this, at this stage now, we'll only be dealing with the power of this MLT. Now, follow me. Let me start from this, the first one here. Do we have M at the left side? We don't have. So the power of M, we are going to include it to be M raised power 0. Don't forget, we don't have M initially, but we are going to include it to be M raised power 0 because NT raised power 0 is 1. So it does not affect anything. So M raised power 0 is 1. So because all this LT raised power minus 1 multiplied by 1, which is this one. So it is still equals to what? LT raised power minus 1. So the reason why we are including it is because M appears at the right side. So we have to make sure that left side is equal to what? Right side. So because M is not initially at the left side, so in order for us to balance it, we just put it to be raised power 0 because NT raised power 0 is 1. So it does not affect. Because that 1 multiplied by all this will still be the same thing. So now, the power of M at the left side is 0. So equals to, what's the power of M at the right side? The power of M at the right side is Z. So this is equation 1. Now what of L? The power of L at the left side is 1 because the power of L here is 1. So we have 1 equals to, the power of L at the right side is X plus Y minus 3Z. This is equation 2. Now the power of T at the left side is minus 1 equals to, the power of T at the right side is minus 2X. This is equation 3. Now, if you check this very well, from equation 1, our Z is equals to 0. From equation 1, z is equals to what? 0. From equation 3, we have minus 1 to be minus 2x. So x will be minus 1 over minus 2. So x will finally be 1 over 2. So if x is 1 over 2, z is 0. So the only thing we need from this is y. So what is our y? Let's calculate for y. Now if you check this very well, our y, we can only get y from equation 2. So from equation 2, we have 1 to be equals to x plus y minus 3z. So 1 is equals to, what's our x? We've gotten x here, which is 1 over 2. So we have it to be 1 over 2 plus, we are looking for y. The minus 3 into bracket 0 because our z is 0 from equation 1. Then we now have it to be 1 is equals to 1 over 2 plus y. Because this one, minus 3 times 0 will be 0. So let us collect the like times. Take this 1 over 2 to the other side here. That's 1 minus 1 over 2 equals y. 1 minus 1 over 2 will be 1 over 2. So 1 over 2 is equals to y. So y is 1 over 2. So let's gather it here. X is 0. X is 1 over 2. Y is 1 over 2. Then z is 0. Then let us go back to our previous equation here from the question. The previous equation says C is equals to K G raised power X, lambda raised power Y, then density raised power Z. Then this is the equation given to us from the question. So C will now finally becomes K G raised power, what's Y? What's X? X is 1 over 2. Then lambda raised power, what's our Y? Y is 1 over 2. Then density raised power Z. And what's Z? Z is 0. Then C will finally becomes kg raised power 1 over 2, lambda raised power 1 over 2. Anything raised power 0 is 1. So density is out of it. So C will now finally becomes K square root of G multiplied by square root of lambda. Because anything raised power 1 over 2 will be square root of it. So C will now finally becomes K square root of, because both of them have square roots. So we can say it is C is equals to K square root of G multiplied by lambda. And this is the correct equation for the question. Now, question number 3 now. Now see this question. It says the gravitational force of attraction F between the particles M1 and M2 separated by distance R is given as F is equals to, so let's solve the solution. It's given as F is equals to K raised power minus X, then to bracket M1, M2 raised power Y, R raised power Z. They said the K is dimensionless. This is force. So the dimension for force is MLT raised power minus 2. Don't forget. So it's equals to K. And they said K is dimensionless. And the dimension for K is this. So we are given. So we now have it to be M raised power minus 1, L raised power 3, then T raised power minus 2. But K is raised power minus X. K is raised power minus X. That's why we should find the value of X, Y, Z. So let's continue. The dimension for mass, don't forget they said particle M1 and M2. So that's mass. We have the dimension for the M1 to be capital M. So multiply by M2 is also capital M. So all raised power Y. We have this to be radius R. We said this distance R. So and distance, that's capital letter Y. Because the dimension for distance is L. So capital letter L. So and it is raised power what? Z. It is raised power Z. So dimension for force is MLT raised power minus 2. Don't forget, I explained the force to you when we are talking about this. Now, the dimension for the K we are given in the question, and this is it. We insert it, but it's raised power minus X. Dimension for mass is capital M, and that's why we have it to be the first M and the second M. and dimension for distance is r, and is l, which is capital L. Now let us open this. We have this to become mlt raised to power minus 2 will now be, this will becomes m raised to power minus 1, n raised to power 3, t raised to power minus 2, all raised to power minus x. And don't forget, m times m here will be m square. So m square raised to power y. Then we have l raised to power z here. Now, we now have this to become, this now becomes mlt raised to power minus 2 will now be equals to, use the power to open the bracket, minus x times minus 1 will be m raised to power x, because anything raised to power, minus times minus will be what? Will be plus. So this one, 3 times minus x here will be minus 3x. So now have this will be m raised to power minus 3x. Minus 2 times minus x will be 2x, because minus times minus will be plus. So 2 times x will be 2x. So we have this to be 2 raised to power 2x. Then multiply this, 2 times y will be 2y. So we have this to be m raised to power 2y. Then this one we have l raised to power z. Now, let us collect the like times. mlt raised to power minus 2 to be. Now let us take all the m together, l together, the y together. Don't forget the sign between them is multiplication. So don't forget the law of indices I told you. So m raised to power x here, then plus another m, which is this, plus 2y. Then for the l, we have l raised to power minus 3x here. Then another l is here, that's plus z. Then for the t, we have c raised to power 2x. Those are the things. So let us segment this into mlt. Now if we are to segment this into mlt, now check, what's the power of m at the left side? That's 1 equals to, the power of m at the right side is x plus 2y. This is equation 1. The power of l at the left side is 1, which is this. The power of l at the right side is minus 3x plus z, equation 2. The power of t at the left side is minus 2, equals to, the power of t at the right side is 2x, equation 3. Now if you check this very well, we can say from equation 3, you have to start from the simple one so it will not give you problem. It's obviously that in equation 3 we can easily get our x. So from equation 3 we have minus 2 to be 2x. So x will be minus 2 over 2. So we have this will be minus 1. Now, we can insert this x in equation 1 so that we can get the value of what? Of y. So from equation 1, we have 1 to be equals to. Now, from equation 1, we have it to be 1 to be equals to x plus 2y. Now, if 1 is equals to x plus 2y, we can say 1 to be equals to, what's our x here? Our x is minus 1 and plus 2y. If you take this minus 1 to this side, it becomes 1 plus 1 to be equals to 2y. 1 plus 1 is 2. So 2 is equals to 2y. So y would now be 2 over 2, which is 1. So y is 1. X is minus 1. So we can get the remaining one from equation 2. So from equation 2 is 1 is equals to minus 3x plus z. Then we have 1 to be equals to minus 3 into bracket. What's our x? Our x is minus 1 plus z. So 1 will now be minus 3 times minus 1, that's 3. So plus z. If we take this one here, that's 1 minus 3 to be equals to z. Then 1 minus 3 will be minus 2 equals z. So that means z is equals to what? Minus 2. So now, let's go back to the equation. So we've gotten the value of x, which is this. We've gotten the value of y. We've gotten the value of z. So that's it. So that's the question. But that's the question we are asked to find. The question says find the value of x, y, z. But in the case whereby you are asked to find the correct equation, so you can just replace it back. F is equals to, from the original equation, k raised to power minus x, then m1 m2 all raised power y, then r raised power z. So f will now be, what's your k? K into bracket minus into bracket, your x is -1. Then we now have it to be m1, m2, all raised power, what's our y? Our y is 1. Then r raised power, our z is -2. So f will now be k, because minus times minus will be plus. So this is +1. Then we now have m1, m2. Then we now have multiplied by r raised power -2. So in short, f will now be k m1, m2. So this becomes multiplied by 1 over r squared, because r raised power -2 is 1 over r squared. So according to law of indices, f is equals to k m1, m2, because all this multiplied by 1 will be what? K m1, m2, all over what? All over r squared. So that's the formula. Now, but what we are asked to find is to find x, y, and z, and we've done that. But in the case the question furthermore, for you to find the correct equation, and this is the way to solve the next question. The question says the period t of a simple pendulum is expressed by this. T is equals to 2 pi the square root of L over G, where L is length, and don't forget L is length. The dimension of L, which is length, is capital letter L, and G is acceleration. So since G is acceleration, don't forget the acceleration has the dimension to be LT raised power -2. That's why we should show that if this formula is consistent, that is, if it's correct. Now, for us to show, we must show that the left hand side is equal to right hand side. So t here, dimension is tt, because it is period. Period is measured in seconds. Dimension is tt equals to dimension of a constant is dimensionless. So pi is the constant and number as well. So you have to remove it. The square root of dimension of L is capital L, all over G is LT raised power -2. Then if you check this very well, L here will cancel L here. So t is equals to square root of, we have what remains at the denominator is 1 over t raised power -2. This is what we mean. Then t will now become square root of 1. Sorry, let's proceed. This will become t is equals to, now inverse of 1 over t raised power -2 will be square root of t square root of t square, because it's like we're having inverse of another inverse of t square. So that's it. So 1 over t raised power -2 will be t square, or t raised power 2, because this is it. If you have 1 over t square will become 1 divided by, 1 over t raised power -2 will be 1 divided by, this t raised power -2 is 1 over t square. Don't forget, according to law of indices. So this t raised power -2 is 1 over t square. So this will now becomes 1 multiplied by, if you change this division to multiplication, that means denominator will become numerator and numerator become denominator. That's 1 multiplied by, so we have t square all over 1, which is this way exchange. So this becomes 1 times t square will be t square, over 1 will still be what? T square. So that's why it is t square. Now if you check this very well, this becomes t is equals to, square root here will cancel the square here. So what remains is what? Is t. So t is equals to t. So that shows that the formula is consistent. So that's how to do it. The next question. The question says, a force F is given by, so let's see, it's given by F is equals to 8c plus bt squared. Now say where t is the time, so t is time, and dimension for time is capital T. Don't forget. Now say what's the dimension for A and B? Now for you to solve for the dimension of A and B, they said force F. Don't forget F, which is force. Dimension for force is mLT raised power -2. So that's force. So what you are going to do here is that split the equation into 2. So you are going to have F is equals to this side, which is 8c, and the other one, F is equals to bt squared. So you can split this because you have additional sign in between. Now, so from here, I can get my A from here and I can get my B from here. So that's it. So make A the solvent formula here. A will be F over t. Make B the sum of formula. B will be F over T squared. So we are asked to find the dimension of A and B. So A here will now be dimension of F, which is force, is mLT raised to power minus 2 over time, which is T. And dimension of B will become force is mLT raised to power minus 2 all over, our T here is capital T, so all square. Now let us balance this. A will becomes ml, because we have ml here, then this becomes T raised to power minus 2. If this one has the T underneath, is that is the T at the denominator has the power to be 1. When it goes up, it becomes what? Minus 1. So A here finally becomes ml, then T raised to power minus 2 minus 1 will be minus 3. So this is the dimension for A. For B here, B will becomes, we have M here, we have L, then T raised to power minus 2. If this 2 goes up, it's positive before it becomes minus. So that's minus 2. So B here becomes mLT raised to power what? Minus 4. So this is the dimension for A, and this is the dimension for what? For B. Now this is where I'm going to stop for today. Now, but the exercise, at the comment section, let me have the answer to this question. Now, what is the dimension? What is the dimension of kinetic friction? What is the dimension of kinetic friction? Option A, we have mLT. Option B, we have LT. Option C, we have MT raised to power 2. And option D, we have dimensionless. Now, we have option A to be MT raised to power 2. Option MLT, that's option A. Option B, LT. Option C, MT raised to power 2. Then option D, dimensionless. So let me know the answer to this question. What is the dimension of kinetic friction? I remain Ishola David Blessing, popularly known as General David. If you want to reach me, reach me on 070-6377-6455. So I believe with this, we are able to scrunch the aspects of the dimensional analysis. Thank you very much for today. God bless you. Like, comment, and help us to subscribe. Just share for other people to use as well. Thank you very much. God bless you.